Hello everyone. I got this beautiful question today while teaching one of my students for IPMET. This question was asked in IPMET 2024 for IIM Indore. Okay. As you can see in the screen, equation was given 4 log x base 2 minus 4 log x base 3 minus 16x plus 68 is equals to 0, and then we have to figure out the value of x minus 2. This question was numerical based. It was not an MCQ. Okay. Cool. So you can pause the video and try to solve it. Once your attempt will be done, you can resume it. Okay. Cool. So I'm assuming like all of you have tried to solve this, and now we can start towards the solution of this. So when I started attempting this question, initial 5 minutes I tried to club all the terms which are having x and try to figure out some solution. Was like my approach was towards the algebra. Okay. And like I tried multiple things, but changing the value of log, changing the value of base, making it same by converting it in the converting it into the base e, and then I was trying to somehow compare this with linear term 16x minus 68, but I was not able to club them together. Okay. And after 5 minutes I thought, okay, we cannot solve it by a traditional algebra method. Okay, we should like approach it in a different way, and this is very crucial while solving any question paper, especially in competitive exam for JEE mains or JEE advanced, that we should not waste our precious time by solving it via only single approach. Okay, it is very important to figure out whether the approach which we are using that will lead to the solution or not. If not, try a different approach. If not, skip the question. Okay, we cannot waste our time during exam. So okay, after 5 minutes I thought, okay, let's what we can do is we can club the value of we can club the logarithmic terms together, and we can club linear terms together. Okay, and try to see like what it gives. So what I did, I did this. I kept 4 log base x minus 4 log x base 3 is equals to 16x minus 68. Okay, and what I'm doing here, I'm just clubbing the log terms in left hand side and linear terms in the right hand side. Now we can divide it by 4 because 4 is common. We can easily get rid of that. Log x base 2 log x base 3 is equals to 4x minus 17, right? Also, as we can see, there are two logarithmic terms, and one is having base value of 2, one is having base value of 3. So we should convert it into some common base. Okay, so what I'm doing, I'm just changing it to the natural logarithm, that is base e, ln x by ln 2. Log x base 2 is nothing but ln x by ln 2, and log x base 3 is ln x by ln 3. This is equals to 4x minus 17. Okay, taking ln x common, what we can do is we can take ln x common, and 1 by ln 2 minus 1 by ln 3, this will give us 4x minus 17. Value of ln 2 and ln 3 are generally, this is ln 2 is 0.69, ln 3 is 1.09. Okay, if you will generally in all competitive exam they do give the value of ln 2, ln 3 or some constants. Okay, similarly I can write e is equals to 2.73. Okay, these are some constants. If I will plug the value of ln 2 and ln 3 over here, this terms will reduce to 0.53. Okay, I have already solved this part, so I can just write it here. This will turn to 0.53 ln x is equals to 4x minus 17. So this is the equation it has been reduced to. Still our problem is same. One term is log, one term is linear, and we cannot solve it right as of now. Okay. What we can do is instead of trying to solve this terms or solving this equation together, what I thought what we can do is I can treat left hand side as a separate equation and right hand side as a separate equation. Okay, so left hand side is 0.53 ln x, right hand side is 4x minus 17. And what if I am able to plot the graph of 0.53 ln x? Okay, if I can plot the graph of this, similarly if I can plot the graph of 4x minus 17, which is nothing but a straight line, and see where these two graphs are intersecting. Okay, if they are intersecting, then there is a solution. If they are not intersecting, then there is no solution of this equation. Okay, so basically what I am doing is I am drawing a left hand side in a graph. Similarly, I am drawing right hand side in a graph and see where these two value intersect. Okay, cool. So this was my approach. Okay, so let's see. Let's draw xy axis. This is 1, this is 2, this is 3, this is 4. Since I just don't want to see the graph, I also want to figure out the exact value of x or approximate value of x where I can get the solution. So that's why it is very important to put some marks so that I can do rough estimation. Okay, so again this is x equals to 1, x equals to 2, x equals to 3, 4, 5, 6, 7, 8, 9. Okay, cool. Let's start with 4x minus 17. This is simple linear equation. Okay, so if I have to plot the value of 4x, plot the graph of 4x minus 17 at x equals to 4, y will be minus 1. Putting x equal to 4 here, 4 4 the 16 minus 17, which is minus 1. At x equals to 5, y will be 3. 5 4 the 20 minus 17. Okay, so okay, cool. What we can do is at x equals to 4, y is equals to 1. Sorry, y is equals to minus 1. So y is minus 1. This is one value. And at x equals to 5, y is equals to 3. This is another value. Okay, and these two points are enough to draw a straight line. If we have 2 points, we can draw a straight line. Okay, so we can get the locus of 4x minus 17, which is nothing but this line. This is the line of 4x minus 17, and if we draw it more down, we know it will at x equals to 0, it will intersect at minus 17. Okay, so this is how it will look like. This is the graph of 4x minus 17. Let's come to the difficult part. Let's try to plot the value of 0.53 ln x. Okay, if I draw 0.53 ln x, this is also simple. Okay, we know ln x, ln is nothing but log base e, okay, where e is 2.73. so when x is equals to e, when x will be equals to e, 0.53 log e will convert to then y equal to 0.53. when x is equals to 1, we all know log 1 is 0. when x is equals to e square, when x is equals to e square, 2 will come out and log e again 1. So 0.53 into 2, y is equals to 1.06. Okay, so this three values we can easily figure out. Okay, so x is equal to e, as I told you, e, the value of e is 2.73. so at x equals to 2.73, which is 1 2, this is 3, so 2.7 is somewhere here. Value of y is 0.53, 0.53, this is 1, so 0.5 here, somewhere above this is one value. Okay, I can use some other color to detect the log. Okay, okay, so this is x equals to e, y equal to 0.53. Similarly, at x equals to 1, y is equals to 0. This is another point. Okay, so we use this at x equal to e square, at x equals to e square, y is equal to 1.06. at x equals to e square, y is equal to 1.06. so e square means 2.7 whole square. 2.7 whole square means something 7.3. okay, e square is 7.3 approximately. So 1 2 3 4 5 6 7, this is 7.3. at 7.3 value will be 1.06. so this is 1, this is roughly 1, it is 1.06. so this is how log curve will look like. Okay, this is the graph of log 0.53 log x ln x. Okay, and as we know, log 0 is minus infinity, so it will go something like this. Okay, so yeah, just by plotting what we are seeing, 4x minus 17, and I can remove this part. E square is 7.3. okay, so just by looking at the graph we can see this 4x minus 17, which was our right hand side. Okay, this term, this white line is our right hand side. 0.53 ln x, this green curve is our left hand side. Now left hand side and right side curve is intersecting somewhere here. Okay, this is between 4 and 5. 1 2 3 4 5, yes. So we can now roughly tell the value of x lies between 4 and 5. We can see like what is the exact value. Okay, also one thing we can see that if we will go more down, somewhere near 0 as well, this two these two curves will intersect. Okay, this two trajectory basically. This is also one of the solution. So this is solution 1, where green line and white line is meeting. This is basically LHS and RHS. This is solution 2. This is solution 2, where again these two parts are intersecting. So are you guys able to like acknowledge the beauty of graph visualization? Just by looking at the equation, we were not even sure that we can find out the solution. I was not even able to figure out whether they have the solution or not. If they have solution, how many solutions there are. Okay, like at how many values of x this equation will get satisfied. But just by simply looking at the graph, we can say there are 2 points where they are intersecting, and hence there will be 2 solutions. Okay, now let's come to the point where we will try to figure out the exact value of this x. Okay, let's see. Acha, can we say definitely this point is in the right side of this point where 4x minus 17 was 0. At this point 4x minus 17 was 0. So this S2 point, solution 2 point, that definitely lies in the right side of it. Okay, so I can say this point is 4x minus 17 equals to 0. So solution must be in the right side, so this value should be greater than 0. So x will be greater than 17 by 4, which is 4.25. Okay, so this is greater than 4.25. Also one thing we can say, we know at x equals to e square, value of y was 1.06 at 6 7 at this is e square, x coordinate is e square and y coordinate is 1.06, and this point at x equals to e value was 0.53. So definitely this S2 lies between this point and this point. So can we say value of y here should be less than 1.06, okay, and hence this point is in 4x minus 17. So can I say whatever the x is here, y value should be less than 1.06, okay, and y value should be greater than 0.53. Y coordinate of this point should lie between 0.53 and 1.06, okay. So what I'm saying, y coordinate will satisfy 4x minus 17 because this is a part of a straight line as well. This point is part of logarithmic curve as well as of a straight line, okay. This point is intersection of this. So I can say 4x minus 17 at the point of solution, at the point of S2, should be less than 1.06 and more than 0.53. If we solve this, it will give you 4x, okay. So if we further solve it, x should be less than 4 4s are 16, 4.5, and if you solve this, 4 4s are 16, 4 3s are 12, and 4 3s are 12, 4 7, okay, this is beautiful. So see how close we are. Now our, initially I thought, okay, solution is between 4 and 5, then we were able to figure out, okay, solution is definitely more than 4.25. Now with this approximation that y should lie between 0.53 and 1.06, I can say x should be lie between 4.37 and greater than 4.37 and lesser than 4.5. How we came to here? Because it should be less than 1.06 and greater than 0.53, okay. Cool. So here it is. We can now roughly say that x should be approximately equal to 4.4, okay. This is my solution towards it. And as question in question it was asked, we have to figure out the value of x minus 2. So x is 4.4, so x minus 2 will be 2.4, okay. So this is the solution. Also write in comment section how we can figure out the value of x in point S1. If you guys want, I can create the next video to figure out the value of x at point S1, okay. So yeah, let's meet at the next video. Also why I'm not interested in point S1 is because this, as initially I told, this question was numerical based, so x minus 2 should be positive, okay, which is possible here only. At this point x lies between 0 to 1, so x minus 2 will be negative, so this solution is discarded, this solution is acceptable, okay. Cool. I hope you guys enjoyed the video and learned how we can visualize the equations and figure out the solutions from them, okay. Cool. Thank you guys. See you in the next video.